spacecraft was lower than intended at Mars, and as a result we are cautiously optimistic that we are just looking in the wrong place at this point in time.
We have just passed 1 minute to atmospheric entry, current altitude 121 miles.
I'm sorry to report that we have a serious problem with the Mars Climate Orbiter. We may in fact be facing a loss of mission.
Hi everyone, I am Raj, and as you watch this, imagine a spacecraft traveling millions of kilometers only to be lost because of one tiny miscalculation. So today, we uncover how NASA lost $125 million on Mars. In the film The Martian, an astronaut, Mark Watney, is left alone on Mars and survives there for over 500 days. Not because of strength, but because of calculations. Because out there in space, every numbers matters, every decision is precise. And later he explained how he survived. And you know what he said?
At some point, everything's gonna go south on you. Everything's gonna go south, and you're gonna say, this is it. This is how I end. Now you can either accept that, or you can get to work. You do the math, you solve one problem, then you solve the next one, and then the next. And if you solve enough problems, you get to come home.
He talks about solving problems, one calculation at a time. Because in space, even a small error can mean the difference between survival and loss. But what if I tell you what we just saw is not just a simulation? In fact, on September 23, 1999, a very similar situation unfolded in real life, when NASA launched the Mars Climate Orbiter, a $125 million spacecraft around Mars, all because of a tiny miscalculation, a mismatch between two systems of measurement, metric and imperial. But what does that actually mean, Raj? So guys, here's the catch. To break it down, we need to start with the basics. And the first of those is force. So what is force? Force is nothing but a push or a pull. So when you are pushing a door or when you are throwing a ball, you are using force. And in space, a spacecraft moves using force. It has small engines, which is called as thrusters, that give it a tiny pushes to change its direction. So if the force is correct, the spacecraft stays on the right path. But what if the force is wrong? Now the path changes. Now the next question is, how do we measure that force? There isn't just one way. There are two systems, the metric system and the imperial system. In science, we usually use the metric system with units like newtons. But there is another system, the imperial system, which uses units like pound force. Both are measuring the same thing, force, but on a different scales. Let me give you one example. Think about temperature. If I say 100 degrees, you will imagine or ask me, is it Celsius or Fahrenheit? Because 100 degrees Celsius is boiling water, but 100 degrees Fahrenheit is just a hot day. Same number, but meaning is completely different. And something very similar happened in this mission. The spacecraft was built by Lockheed Martin, which is a aerospace spacecraft company, and their system used the imperial unit, while NASA's navigation team was working in metric. Individually, both were correct, but together they did not match. And here is the key difference. 1 pound force is about 4.45 times larger than 1 Newton. So if you don't convert properly, you don't just get a different number, you get a completely different force. So what actually went wrong? Two systems measuring the same force but using different units. And the difference was about 4.45 times. That means every calculation was up by more than 4 times. So instead of a small correction, it was receiving a much more stronger push. And it did not happen once. It happened again and again with every correction. And in everyday life, that might confuse you, but in space, it changes trajectory. And in this mission, that difference was never corrected.